So, lesson natin today mga Lodi, deflection due to impact loading. Now, this happens when a mass or any weight strikes and sticks at any point of the beam from a certain height. Now dito, we have a pro diver who jumped at this height and then babalik siya dito to spring himself up para mag-dive. So, diba, we can define this height as H. And then, let's assume fixed support dito sa right end. But, this is not essentially a fixed support kasi spring kasi ang nandyan. But, for the purpose of simplification, gagawin na lang natin fixed. And then, di ba, we also have the mass of the person. Now, medyo fit kasi siya. So, sabihin natin, yung weight niya is 65 kilograms. Yan. And then, di ba, yung centroid of mass ng human body, that's located close to the chest. Now, this is the free end of the beam. Move na lang natin. Yan. And so, di ba, we need the cross-section of the beam then. So, sabihin natin, dito, mas malaki yung width kesa sa thickness. So, we have this figure. Sabihin natin, yung thickness is 30 mm and then the width is 200 mm. Yan. And then, since this is wood, ano yung modulus of elasticity ng wood? Diba, this is usually around, sabihin natin, 10.3 GPa. Now, what is the moment of inertia about the x-axis? Diyan kasi magbibend yung beam natin or yung wooden plank. So, this is the x-axis. Computing Ix, we have, diba, our general formula for Ix is BH cubed divided by 12. This is the centroidal moment of inertia. Now, we have here 200 times height, which is 30 cubed divided by 12. And so this is mm to the fourth. Yan. Now first, in calculating deflection due to impact loading, we have to first solve the static deflection. So move natin to. Again, this is the beam section. And so now, diba, when he falls to this height, this is now the figure. Now, static deflection defines the deflection when only the weight acts. So, diba, yung mass ng man is 65 kilograms. Converting this to newtons, we have times 9.81 meter per second squared, we got 637.65. Yan. And so, the static deflection is, label natin as delta S. Diba, this is a cantilever beam with a load at the free end. So, we can use PL cubed over 3EI. Yan. Now, what is P? P is the load. This is 637.65. And then, let's just assume the length of the beam. So, sabihin natin, this is 2 meters. Yan. And so, plugging in the values, we have this is 2 meters and then cube. But we have to convert this into mm so that our units will be consistent. So, we have to multiply this by 1,000 cubed. Yan. And then, divide natin by 3EI. So, we have 3. And then, our E is 10.3 GPa. So, convert natin to MPa by multiplying it by 1,000. And then, our Ix is 200 times 30 cubed. Divide natin yan by 12. Yan. Now, solving the static deflection, we have 637.65 times 2 cubed times 1,000 cubed, divide natin by 3 times 10.3 times 10 to the third, and then times 200 times 30 cubed, divide natin by 12. And so our static deflection is 366.86. And then this is, naka-mm na yan. However, this isn't still the deflection experienced by the beam. Now, if we will try to check, medyo malaki yung deflection. Now, bakit? The deflection is higher kasi diba, yung impact increases the deflection. So that's why we have to multiply this by a factor which we can obtain using this formula. We have the impact factor equal to 1 plus square root of 1 plus 2h divided by the static deflection. Now sir, what is h? Sabihin natin na the height of the man's feet from the plank, let's say this is 300 mm. Sabihin lang natin. Now if this is 300 mm, then that will define our h, because h is the height at which the object falls from. So the impact factor is denoted by n, and so we have 1 plus square root of 1 plus 2 times h, which is, this should be in mm. Kasi diba, the static deflection is in mm. The units have to be consistent. So divide this by 366.86. We can get the impact factor. So plugging this in, we have an impact factor of 2.62, or let's just use 3 decimals. We have 2.623, and this is essentially unitless. Now, this isn't still the maximum deflection. This is still the impact factor. So how can we solve the maximum deflection? For the maximum deflection due to impact, we have n multiplied by the static deflection. So this is now 2.623 multiplied by 366.86. And so solving the maximum deflection due to impact, we have this value, so press answer times 366.86. So we have 962.43. And so as you can notice, malaki talaga yung effect ng impact. From 366.86, yung deflection naging 962.43. And so this is now our final answer. Pag di yan yung sagot mo, ito ang magiging score mo.
0, 0, 0, 0, 0, 0, 0.